Chapter 1, Part 3. So continuing our look at the program that we started analyzing in the last part, you'll notice that in the system.out.println, and there's parentheses, and then inside those parentheses, there's the words hello world in double quotes. Those double quotation marks denote a string. A string is just a sequence of characters. We can't do math with it. It's just text. And a string can contain anything. It can contain numbers, it can contain punctuation, but the double quotes, the start double quote and the end double quote denote the beginning and the end of what's known as a string. You can also print out numerical values. So if we have system.out.println 3 plus 4 in the parentheses, the math will be completed, so it'll evaluate the expression 3 plus 4, come up with 7, and 7 will be displayed in that console output window. System.out.println prints whatever's in parentheses, and then it is the same as hitting the enter key. It goes to the beginning of the next line. So that 7 would be on a line all by itself, and any print statements that follow would be on subsequent lines. So if we have the statements system.out.println hello, and then system.out.println world, it will print hello and world on two separate lines. There is another method called system.out.print that does not hit the enter key after it displays something. So it leaves the cursor on that same line ready to print whatever follows. So system.out.println prints what's in parentheses and then returns to the beginning of the next line. System.out.print prints what's in parentheses and then stays right there at the end of whatever it was that it printed. There are basically two types of errors in Java. One is a compile time error. It happens when you hit the green triangle to run the program, and it has to compile it first, translate it from source code into object code, and it comes up with something it can't figure out. It can't translate it. Think about talking to someone who might not speak English. I went this summer, I was over in another country where they didn't speak English, and I didn't really speak the language. They were so kind and patient with me, but believe me, I'm sure what I was putting together was very hard for them to understand, if they understood it at all. Frequently I got blank looks. And that the same is true when you're hearing someone else who's not speaking the language that you're familiar with, or when you're trying to type up a statement for the computer and the computer can't make sense of it. That's known as a syntax error. An example is shown here, system.out.println, hello world. We forgot the T in out. That is an example of a syntax error. The program will not compile. It will get red squigglies under it in NetBeans, and you'll get an error message saying, I can't do this in some form or another. The second type of error is known as a runtime error. Runtime errors can include logic errors. And some people say that all runtime errors are logic errors, but that's up for debate. We'll talk about the differences shortly. Basically, a runtime error happens at runtime. So your program has compiled correctly, and Java can figure out everything you want to set, you're trying to do, and it runs it, but then it runs out. It has a problem. It does not produce the output you expect, or it does not behave in the manner that the programmer expects. For example, if we have system.out.println hello world, we wanted to display hello world, but we left out the L. That's an example of a logic error. Other examples of a logic error you may have heard about 20 years ago. The United States was trying to send a probe up to Mars and launched it, and everything was great, and the thing's about to land, everything's good, and then all of a sudden it crashes into the surface of the red planet and blows up. Billions of dollars, gone. That was an example of a logic error. The programmers in one part of the team had used the metric system, and another part of the team they'd used the English system, and so feet and meters, nobody did the translation, and so the space probe misjudged the surface of the planet. That's an example of a logic error. Program runs, just doesn't do what we expect. Another type of runtime error is an exception. An exception basically means an exception to the normal running of a program. It didn't run normally. And that will generate an error message from Java. For example, if you have system.out.println 1 divided by 0, you will get a divide by 0 error message because you can't divide by 0. That's not defined in the real world, and it's not defined in programming either. I noticed another error that I should have fixed before starting to record this. System.out.println 1 divided by 0. there should be a semicolon at the end of that line. That is an example of a syntax error. So we have a syntax error and we have a logic error in the same statement. However, the syntax error would be caught first, and we never would encounter that logic error until we put a semicolon at the end of that line. Problem solving. You can't write a computer program to solve a problem that you don't know how to solve yourself. So you have to develop an algorithm. And an algorithm is a sequence of steps that is unambiguous. There's no debate about what it is you're trying to do. It's executable. You can hit the run button and it will be able to run. And it ends. It doesn't run forever. I like to say that an algorithm is a step-by-step instructions that solve a problem in a finite amount of time. And an example can be a recipe, or rules for a game. Let's say you all want to play Monopoly and you've never played before, you have to read the rules. That's the algorithm. A recipe, you have to follow the instructions to come up with the chocolate chip cookies at the end. So those are all examples of algorithms. How are you going to solve that problem? Many times early programmers start to jump in and write code before defining the algorithm first, and that's a mistake because you're going to wind up throwing a lot of code at a problem and perhaps not ever really solving it. So it's important to think about how to solve the problem first before you translate it into code. For example, this is an algorithm for solving an investment problem. The problem is you put $10,000 into a bank account that earns 5% interest per year. How many years does it take for the account balance to be double the original? So how many years is it going to take till I have twice as much as I started with? Notice that we can calculate it by hand. We draw a little table. We've got a column for the year and a column for the interest and a column for the balance. And if we start out with, looks like we started out with $1,000 instead of $10,000. But no, there we go. Okay, 10,000. In programming, you're not going to have the comma at the thousands place, which makes it more difficult to read. However, the compiler can't figure out what the comma means. And you'll find in other languages that they don't necessarily use a comma in the same place that we use a comma in the US. So at any rate, balance is 10,000. Our interest after the first year is we calculate that 5% interest on our balance, and then we have to add that interest back in, and then in the second year we get our interest on 10,500 and we add that back in, and so on, and we have to keep going until we figure out how many years it's going to take to have double the original. At what year am I going to have $20,000? So our steps for the algorithm, we start with the year 0, we start with a column for the interest and the balance of $10,000. We repeat the steps, so we're looping, we're doing the same thing over and over, as long as the balance is less than 20,000. So we add 1 to the year value, we calculate the interest, and then we add it to the balance. We do it again. We add 1 to the year, calculate the interest, and add it to the balance. You'll see that at 5%, it takes 15 years until we have double the original, and you'll see that right down there at the bottom of the table on the bottom of the slide. So pseudocode is another way of expressing an algorithm. So I like pseudocode because it's English-like statements that describe the steps to solve a problem. So you don't have to worry about the syntax or whether or not you're writing it in Java. You just write it out in English. I try to think of giving someone else instructions who doesn't understand how to do a problem. You would just write step-by-step instructions. So pseudocode allows us to do that. We can describe how a value is set or changed. So like total cost equals purchase price plus operating cost. Multiply the balance by 1.05. Remove the first and last character of word. Each one of those is just a description of something that's happening. You can describe decisions and repetitions. If the total cost 1 is less than the total cost 2, so that's an if statement, while the balance is less than 20,000. Keep doing this for each picture in the sequence. So each of these are just English descriptions rather than lines of code. You can use indentation in pseudocode to indicate what statements would go with another statement, but it's not required. And then you can also indicate the result, like you would say, choose car 1, or report the final value as the answer, or print something. Here's an example of an algorithm using a graphic. This is kind of a simple, oversimplified flowchart. We're going to get into flowcharts as a planning tool later on, but this is really important. for algorithms, you have to understand the problem first. The programmer has to understand the problem. They have to develop an algorithm to solve that problem. They have to test the algorithm. So you've developed these steps. Go through the steps, testing it yourself to see if you get the output you expect. Then and only then do you translate that algorithm into Java and compile and test your program. Testing is really, really important because you can write code that runs but doesn't produce the output that you expect, and you'll never know that unless you test it.